I am doing my presentation on dams and their impact on the environment. A dam is a hydraulic structure that is constructed across a river to form a reservoir on its upstream side for confining water for various purposes. There are many reasons dams are used. Some of the major reasons are for hydropower, flood control, recreation, and irrigation. In different climates and landscapes, dams have different functions, so each dam is constructed depending on the purpose for which they will be used. Two-thirds of the world's fresh-flowing water to the ocean is obstructed by dams, and even more rivers are constrained by artificial levees and dikes. And this is terrible because any dramatic change in river composition stresses both downstream and upstream habitats, and habitat loss is the leading cause of extinction. Current projections project that global population is expected to increase to nearly 10 billion by 2050, which will double the world's energy demands. Furthermore, there are increasing concerns about how to meet these needs without causing irreversible damage to ecosystems. And even though this number is outdated, it shows that building of dams isn't slowing down. But in 2014, 3,700 hydropower dams were in the planning or construction phase worldwide. What's even more startling is that in the U.S. alone, there are 15,000 dams that are classified as high hazard potential, or HHP, and that the greatest gas emissions from the use of dams comes from shallow tropical reservoirs. This is a diagram of a gravity dam, the type most people associate dams with. It shows how water is held on the upstream side and that when it reaches a maximum level, it will go through the spillway. The crest or the top of the dam is usually a sidewalk or roadway. The heel and toe are where the dam meets the riverbed upstream and down. The sluiceway, I'm not sure if I said that correctly, is the opening used to clear accumulated silt against the reservoir. When a dam is built, it changes the water level and alters flow. Most free-flowing rivers consist of a series of rapids and slow-flowing stretches, whereas in strongly impounded rivers, dams have been erected on the rapids. This is essentially converting the rivers into stairs of reservoirs, as pictured, where there are nearly no rapids left. An example of where this has happened is on the Mississippi River. Diversion dams which divert water from a river to a conduit or canal. Detention dams are built to take care of floodwaters and release stored water slowly. Debris dams are constructed to retain debris from the river and it catches sand, gravel, and driftwood. Pictured here is a coffer dam, and they are temporary dams that are used in construction to keep the site dry. The other types of dams are those based on structure and design. Gravity dams are extremely large. They're made of stone or concrete and are designed to hold large amounts of water. Earth dams are made of soil that are compacted, whereas rock-filled dams are a type of embankment dam that uses various sizes of material to provide stability. Arch dams are curved with convexity towards the upstream side. It is best used in narrow canyons. The Hoover Dam is an example of this type. Buttress dams are also called hollow dams and hold water back by a series of buttresses. It does not make a straight line. There are three types: a deck, multiple arch, and massive head buttress. Steel dams are comprised of steel frame and steel plates on the upstream side. There are two types of steel dams, the direct strutted and the cantilever. Timber dams are made of wood and are good for small waterways and have wooden shields that can be raised and lowered to allow water through. What dams do to the waterways and their inhabitants is catastrophic. And I think it's worth mentioning again that any dramatic change in a river's composition stresses both up and downstream habitats, and that habitat loss is the leading cause of extinction. Dams can cause water temperatures to change, and they disturb flow and composition of the water within rivers and channels. Water released downstream from dams have unnaturally high energy and very little sediment, which causes water to run forcefully, essentially eroding the riverbeds. Without sedimentation, the fast-flowing water deepens the riverbed, which causes the groundwater to rush into the channel and become surface water. This process is called incision. The USGS reported that between 2000 and 2008, the U.S. depleted enough groundwater reserves to contribute to 2% of the global sea level rise during that time. Furthermore, water storage in reservoirs induces physical, chemical, and biological changes, which affect the water chemistry. This means that the water discharged is often very different composition to that of the inflowing river, and water released near the surface is generally well oxygenated, warm, and nutrient depleted, where water released near the bottom is usually cold, oxygen depleted, but nutrient rich, and it may be high in hydrogen sulfide, iron, and manganese. And bioaccumulation results in levels of methylmercury in the tissues of fish at the top of the food chain, and several times higher than that in small organisms at the bottom of the food chain. This is having serious implications for people who depend on fish as a large portion of their diet. Dams cause ecological changes in a riparian ecosystem. A riparian ecosystem is the ecotone between the upland and aquatic realms and is sensitive to a variation in the hydrological cycle. These ecosystems can be defined as the stream channels between the low and high water marks and the terrestrial landscape above the high water mark. And these ecosystems include a variety of community types, including spruce forest on periodically frozen grounds and dense moss with floodplain landscapes that have deciduous trees and shrubs where deltas are well defined and they have a diverse animal community. Flooded soils and vegetation release greenhouse gases while they decompose. This contributes to global warming. New riparian zones are created, and they can lead to an invasion of exotic species, plants, and animals, including invasive species. What's happening to the riparian succession after damming? Upstream dam construction, drought, and natural channel changes have left large areas of the Hadyajama area floodplain decimated, degrading riparian forests and other wetland ecosystems. Inundation leads to loss of habitat, organisms, and leads to further environmental problems for both people and animals. Inundation can also lead to the increase in aquatic productivity, which can be bad because it contributes to greenhouse gases that predatory fish then absorb through their food and increase plant growth, which can have other negative effects. Excessive growth of plants may reduce access to drinking water, taint potable water, cause increased evaporation, and mess up pump intakes. What happens to the riparian succession after damming? Well, following a reduced flooding regimen downstream from dams, there are ultimately four scenarios of change that can occur, individually or with various combinations, resulting in the extinction of native riparian species. The final result is a reduction of riparian diversity. Unfortunately, most of these changes occur during the first decades after damming. When dams are built in arid climates, salinization can happen. Salinization is the process by which a non-saline soil becomes saline. Dieback happens when saline groundwater comes to the surface because the floodplain waters have not recharged it. Irrigation can cause saline groundwater to rise, leaving salt behind when the water evaporates. Flora and fauna suffer major losses in these habitats. The blowing of this salt and dust can lead to health hazards and increase the rate of desertification. This diagram showing the process of salinization in arid lands shows that water infiltrates and percolates into the soil of areas under crop cultivation. The irrigated area is subject to very heavy soil and water losses. The salts contained in the irrigation water remain in the soil and increase in concentration, and when the percolation of large volumes of water, this can cause a rise in the water table and may in time bring the zone of saturation close to the surface. This is known as waterlogging. When the water tables rise to the point at which upward capillary action can bring water to the surface, evaporation is increased and salinization is intensified. Proof that dams are hurting the environment and contributing to global warming. The Snake and Columbus rivers both have been heavily dammed and both have seen negative effects of damming because both have lost a species of salmon. Water evaporation is increasing every year. About 170 cubic kilometers of water evaporate every year from the world's reservoirs. This accounts for 7% of fresh water consumed by human activities. A recent study found that reservoirs account for about 4% of human-made climate change. The Aral Sea is another example of devastation from altered river hydrology. Increasing amounts of water were abstracted from the largest tributaries of the sea, causing an 80% decrease of water volume in less than 40 years and an increase of salinity over the first 3 decades, so much so that the sea is now saltier than the ocean. The shrinkage of the sea has affected flora and fauna because they have suffered massive losses to habitat, not to mention the enormous amounts of salt and dust that are blown into agricultural lands contributing to desertification. And the millions of hectares of exposed seabed are causing deterioration of both human health and soil fertility. Pictured are the unification of the Mackenzie River before and after damming, which caused the loss of habitat via islands and sheltered streams, resulting in a 50% decrease in salmonoids. And the smaller image is of a map showing river orders before being dammed. Dam failure. What causes it? There are 5 main reasons dams fail. Overtopping is caused by water spilling over the dam. Foundation defects include settlement and slope instability and account for 30% of all dam failures. Cracking is caused by movements, essentially settling of the dam. Inadequate maintenance and upkeep is human error. And piping is when seepage through a dam is not filtered correctly and soil particles continue to progress, forming sinkholes in the dam, which account for 20% of dam failures in the United States. Pictured is a picture from a Buffalo Creek Valley, 1972, after the failure of a coal waste impoundment at the valley's head took 125 lives and caused more than $400 million in damages, including the destruction of over 500 homes. Dam failures in the United States and the resulting consequences. From 1972 to 1977, several dams failed in the U.S., causing millions of dollars in damage in multiple states and killing more than 300 people. Prior to these failures, and in 1978, there were no laws or regulations regarding dam safety. But President Jimmy Carter directed the USA Army Corps of Engineers to inspect the nation's non-federal high-hazard dams, and what they found was alarming. But the findings helped create a national dam safety program, which all states have adopted the program except for Alabama. This map shows dams and their condition in the United States according to FEMA. Approximately 15,000 dams in the United States are classified as high hazard potential, meaning that their failure could result in loss of life. Dams have been identified as a key resource of our national infrastructure and that they are vulnerable to terrorist attacks. States have the primary responsibility for protecting their populations from dam failure. And of the approximately 94,400 dams in the United States, state governments regulate about 70%. Dam failure and outdated infrastructure mean different things for people than it does for the environment and other living beings. For people, there is the risk of flash flooding, polluted drinking water, property damage, disruption of utilities, shortages, and loss of life, whereas the environment will suffer through contamination of waterways and the destruction of fisheries and other habitats that will essentially affect birds and other animals as well. Furthermore, when a dam fails, the destruction on fauna and other living things will create greenhouse gases contributing to global warming, and ecosystems will be deprived of essential nutrients. Overall, outdated infrastructure isn't good for people or the environment. Consequences of dams on people globally. Benefits have usually been to urban or industrial areas, as that is where most governments and businesses are willing to invest. Many river people downstream from dams have been negatively affected and displaced and essentially lose their livelihoods because they are no longer able to make a living the way they used to. The building and creation of new dams can lead to food insecurity, health complications, and social disruption and can affect generations. Businesses and governments can be corrupt, looking out for themselves. An example of this is in 2000 when the World Commission on Dams, the WCD, brought attention to the building of large dams. However, they only documented those being misplaced by dam construction, not the 40 to 80 million people affected downstream. The future of dams. Hydropower without building new dams. Increasing need for energy has increased, but building dams is costly and disrupts ecosystems. Some mapped, non-powered dams can be upgraded or retrofitted with hydropower possibilities with minimal additional damage to the environment. At the time the information I'm presenting was written, there was 20,574 dams identified as NPDs or non-powered dams, and of them identified, 72% of mapped dams do not include hydropower as a designated use. If alternatives to new construction were pursued globally, it could reduce the planned capacity for small hydropower dams and large hydropower dams by 11%. Mapping of global dams are needed to continue to develop an understanding of the complete potential resources that is available and how to adjust for alternative strategies for new hydropower development. The future of dams and environmental protection measures. It seems that hydropower is here to stay and that dams will continue to be used, but the future of dams could be minimized through environmental protection measures such as avoidance measures, which are the use of alternatives like water recycling and rainfall harvesting, or mitigation measures, which are the most common, that can alter the dam or its operation to minimize negative effects. There's also compensation measures that can be taken that include the preservation of existing ecologically important areas. Another possible option is rehabilitation, and these efforts can also be made on previously disturbed land. Thanks everybody for listening to my presentation. This last slide is the sources I used. Thanks again.